Hello, how we doing today? Hope everybody doing well today. What we're going to do, we're going to solve this equation right here in terms of x. So, let's get started, shall we? Now, the first approach to this, right, you might think, we can use separable techniques. Okay, let's divide everything by y. Notice that we got y on both sides. This is okay. This poses us a problem because if we were to accommodate for this, right, this is when you're a wrong solution. Off the top, I know it from experience. Therefore, we have to use another technique, and this technique is called integrating factor, right? So integrating factor is a fact that we have to use some number, right, raised to the e integral of p of x dx. And we're going to use this and multiply it throughout and see what we can get, okay? So let me go ahead and get rid of this and we shall get started. Alright. So let's bring everything over to the one side of the equation. So we get out your way and let you see how this is done. So we have y minus, actually plus y. Then we'll subtract 2 from both sides. That gives us 0. Now the second thing you want to do, right, you want to divide by this. Why do you want to divide by this? You got y plus a constant. Remember, we tried the other way, so we're going to, in this case, divide by this first, right? Another method, okay? Another method. So let's go ahead and divide by this first. So we have y squared, actually no, y squared, y1 divided by y minus 2 plus 1 equals 0. Erase that. Okay? So yes, this can be solved, but it's separable, right? It's one technique. It's really cool. So now we can write this in terms of their logarithms, right? So let's go ahead and solve for this. So we got y over y minus 2 equal to negative 1. Okay, simple. Then we take the integral of both sides. 1 y minus 2 respect to y equals negative 1 respect to x. So this becomes ln of y minus 2 equals negative x plus c. Our final answer is, because we're going to raise both sides to the e, right? And then we have y minus 2 equals c equals x, loss of exponents. And our final answer will be y equals to 2 plus c e to the negative x. Guys, I hope you find this very informative. That's very important. So that's what I wanted to show. Then we're going to stop right here and start with part 2. So we're going to pause. Now we are back for part 2. Let's continue. So now we're going to use what they call integrating factor. Okay. So let's go ahead and rewrite this equation. And we're going to do the opposite. So we're going to add 2 to both sides. Because this is in a form of, we'll put the side over here. So this is in a form of, we'll just describe it. So this would be p of x, q of x, right? Constant variable. All right, we wanted everything in terms of x. So here we go. So we're going to take the integrating factor with respect to what? Y equals, actually x. So this is going to be e to the integral of dx. So therefore, this will give us e to the x. The integral of 1 is x, okay? Very important. Now we're going to multiply it throughout, okay? So we'll multiply e to the x, y prime, plus e to the x, y equals 2e to the x. Okay? Now we write this as a product. So e to the x, y prime equals, okay, 2 e to the x, so it's going to be x, right? No, we good. So we got, this is going to be 2. It should be a negative 2. We say e to x 2. Alright, so 2 e to the x, the integral of 2 e to the x is e to the x. Plus c. That makes sense? Constant. So this would be 2 e to the x. Integral e to the x is that. And plus your c. Alright, everything looks good. So now we're going to, of course, this is your integral here. So we're going to bring this out. E to the x. Y is equal to 2e to the x plus c. Divide everything by e to the x, right? So we have y equals 2e to the x divided by that gives you 2, plus c equals e to the negative x. And that's our final answer. Now, let's say we give an initial condition of y of 0 equals 0. Alright, we'll do that in step 3, guys. We're going to pause the video and we're going to go to step 3. Okay, guys, part 3. Here we go. So now we're going to find our constant, guys. So we're going to set everything equal to 0 here, then our x is 0, right? So remember, this is going to be 2 plus c e to the 0 power equals 0. So 2 plus c times 1 equals 0. So we got 2 plus 1 times c equals 0. And therefore our c is equal to negative 2. Therefore c equals negative 2. Now we put it back into the original equation. So this would be our new equation. Y equals 2 minus 2 equals 2 minus 2 c to negative x. And we'll do this, or you can just write like this: 2 1 minus e. Okay, 1 minus e to the negative x. Either or is acceptable. And here's why it's important, right? And we're going to talk about the last thing. So if you notice, we got this down, right? So we're going to talk about something, right? So thirdly, we're talking about the characteristics of this. All right. So we got the solution. So I'm gonna go ahead and talk about the characteristic of this equation. So part 2, initial condition. So we have y equals 2 1 minus e to the negative x. Okay. And thirdly, we do a graph, right? So we want a graph. All right. So that's the thirdly. So we're gonna talk about the characteristics of this, right? So let's say we're going to compare, right? This is our 2 minus our 2e to the negative x. And we're going to write this as 2 minus 2 over e to the x. And let's see what happens when we use the limit as this goes to infinity. As this goes to infinity, so... And this would be 2 minus 2 over e to the x. Use the limit laws, and guess what? We got 2 minus 1 over infinity. And you have 2 minus 1 over infinity will be 0. So guess what? Our limiting factor is 2. No matter what, we bound it. That's our limiting factor. Is 2. All right? So this means our n is greater than or equal to 2. So this is a particular solution. So yes, this is a particular solution. So if I were to draw the graph of this, right, let's say graph this right here. So we got to do a graph of this. So we got our limiting factor, okay? That's just for that particular instance. So our limiting factor. So let's see what happens as it behaves towards, 2. So we draw a little graph here. And 2 going to be right here, right? So let this be y equals 2. So it's at y equals 2. And anything above here, right? So above here, it's going to be looking like this. It looks like it's going like this, right? Look like a straight line. So that's our graph was. Look like a straight line to me. All right. So it's going to go this way, but like a straight line. And only our solution, in this case, all right, it's bounded by this line. Or if it's greater than that, it goes above it. Look, it's bounded by that line. So that's our limiting factor. Okay? So guys, I hope you enjoyed this video, and thank you for watching, and I hope you learned something. All right, have a great day. Bye-bye.